So in this video we're going to look at graphing cosine and sine functions that have horizontal and vertical translations simultaneously. So the first example, we have a function f of x equals 90 sine pi over 10x minus pi over 5 plus 120. So we can see, because we're subtracting something from the input variable, that there's going to be a horizontal translation, and we're adding something to the function value, so we're going to have a vertical transformation as well. So we can kind of go through and just categorize things real quickly. We see from here that the amplitude of the function is 90 units. The plus 120 is going to move our midline, which is usually y equals 0 or the x-axis, up 120 units. So the midline is going to be 120 units. The period of the function is going to be affected by this pi over 10 times x. So usually the period of a sine function is 2 pi, but now we're multiplying it by a number that's close to 3/10. So things are going to be happening slower than they usually do. So that's going to impact our period. So we can figure out what the period is. We can say, hey, pi over 10 times x, this piece here, we ignore the horizontal translation for just a minute. We say, when does that equal 2 pi? And then I solve for x to see what value of x generates 2 pi. And I see that I need to multiply both sides by the reciprocal of pi over 10. So we'll multiply both sides by 10 over pi. When we take the product of reciprocals, we get a 1. So 1 times x is x, equals pi divided by pi is 1. So we get 2 times 10 is 20. So the period of the function, period, is going to be 20, which means the distance between tick marks, when we break it up into 4 even pieces, is going to be a fourth of 20, which is just 5. That will be the distance between tick marks. And now we need to figure out what that horizontal shift is, and we do that by factoring the pi over 10 off of the x, so that we can determine what number is actually being subtracted from a single x. So I pull off the pi over 10, which is going to leave behind x minus 2 plus a 120. So we would verify this by distribution. Pi over 10 times x is pi over 10x, minus pi over 10 times 2 is 2 pi over 10, which reduces to pi over 5. So we have a horizontal shift. Horizontal shift is going to be 2 units. And that's going to be, because of the minus, it's going to be 2 units to the right. And the midline right here really represents a vertical shift of 120 units up of the entire graph. So you can kind of start to put together the function. I'm going to establish my vertical axis. So here's my f of x axis. The midline is sitting up here. At 120. The sine function usually starts right on the vertical axis, but in this case it's going to be shifted 2 units to the right. So we do that horizontal shift. We're going to start drawing here. So we just pick a spot to be 2 units over, and then there's no reflection, so I'm just going to draw what the sine function usually looks like. He goes up to his highest point, he comes back down to the midline, he drops down to his lowest point, he comes back up to his midline. So there's one full cycle of the cosine function. The amplitude is 90, so the highest point is going to be 90 units above the midline. So 90 plus 120 is 210. And the trough is going to be 90 units below the midline. So 120 minus 90 is 30. And so this distance, if this distance is 90, then the x-axis should be kind of close to the 30. So I'm going to draw that in. We break this into 3 equal chunks. Each of those would be 30s. So we'll put the x-axis fairly close. Unfortunately, I have this extra bit here. I'd erase it if I were working with pencil. This is the x-axis. I have my arrows on my axes. My axes are labeled. My midline is labeled. And I know this is horizontally shifted over 2 units. The period we determined is 20. So right here it's got to be 20 units away from this. Needs to be 20 plus 2 is 22, because the period should be the distance between those 2 points. 22 minus 2 is 20 units. There's my period. And then we set a fourth of the period. If we're breaking this into fourths, high point, cross the midline, low point, back at the midline. So we break it into fourths. So we take a fourth of the period. That tells us that the distance between each of these should be 5. So we go 2 plus 5 is 7, plus 5 is 12, plus 5 is 17, plus 5 is the 22. And there's a nice graph of our horizontally and vertically transformed function. So another example, here we have f of x. Let's clean this up a little bit. F of x equals -3 cosine, factor the 2 off so I can see what the horizontal translation is, and then it's plus a 4. So kind of rewriting it in this form, but factoring off the 2 so I can see what the translation is. The horizontal translation, I have a horizontal translation of pi units, and though there's a minus, so it's pi to the right, pi to the right, plus 4, so the midline is going to be raised up to y equal to 4. The midline will be at y equals 4, or we have a 4 unit upwards translation of the entire graph. Amplitude is 3. I do have a negation on the amplitude, so we're going to have a x-axis reflection. And have we taken care of everything? We've got, oh no, we need to take care of finding the period. So we have a multiplier of 2 on the input variable, so everything's going to be happening twice as fast. So instead of 2 pi radians, my period should be pi radians. We could verify that by saying, when will the input 2x equal 2 pi? And if we divide both sides by 2, we get pi. So the period is pi units. And then we can kind of think about graphing our function. So the period is pi, and we have a horizontal shift of pi units. So if I think about my horizontal axis for just a minute, I'm going to be putting a vertical axis in. So here's my f of x axis, and I'm going to be shifting pi units over. So a period, the period is pi, so one full period I should get going out to 2 pi. So cosine function, let's establish a midline. So here we go, midline coming in. I'm going to start drawing my cosine function right here. The cosine function is usually up high, but I'm going to reflect over the axis or midline, so I'm going to reflect down. I'm going to start low. And I want to draw it in about this distance. I'm going to come up to my midline, up to my high point, back to my midline, back down to where I started, and this is going to be pi plus the period is pi. So pi plus pi is 2 pi. That actually tells me the picture should completely repeat itself between here and here. So I'm not going to draw it, but it should completely repeat itself in there. So my midline is at 4. Everything's shifted up 4. My high point should be at 3. So the high point is 3 above the 4. Sorry, the amplitude's 3. Here's f of x. 4 plus 3 is 7. 4 minus 3 is, the low point should be at 1. And the tick marks, they're nice and even. So there's crossing the midline, high point, low point, midline, high point, midline, low point. So if the period is pi, then the distance between two tick marks should be 1/4 of pi, because we're breaking it into 4 even-sized chunks. So that's just pi over 4. So an easy way to do this is to get a common denominator right here. Write pi as 4 pi over 4. And then we know that each of these is a distance of pi over 4, so we can just count up 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And this one here would be 8 pi over 4, which reduces to 2 pi. And if you felt compelled to, you could come in and reduce this and reduce this. This would reduce to pi, and this would reduce to 3 pi over 2 in simplest form. And we'll put our x's on our horizontal axis. And there's the graph of the function.